Today discuss weak acid dissociation. First, let's see common formula for acid. Normally we use HA formula represent for monobasic acid. HA represent monobasic acid. We can use represent strong acid and weak acid. This HA we can use represent the strong acid and weak acid. H2A, this is the represent dibasic acid. We can represent this H2A strong acid, weak acid. H3A tribasic acid, this H3A can represent strong acid and weak acid. Now we discuss weak acid dissociation. We know what is the weak acid. Weak acid is weak acid. Weak acid means they are partially dissociate in the aqueous solution. Partially dissociate in aqueous solution. Think we have acetic. Acetic is weak acid. We add 1 mole acetic acid in water. This acetic acid dissociate acetate and H plus, but not convert fully this 1 mole. Convert from 1 mole very low amount into acetate ion and H plus. Therefore, we call weak acid partially dissociate in aqueous solution. Example for weak acid: all carboxylic acid. All carboxylic acid are weak acid. Formic acid, acetic acid, benzoic acid, all carboxylic acid are weak acid. HF. HF is weak acid. HNO2, HCN, H3PO4, H3PO2, HOCl. These are normally we use weak acid. Let's see dissociation constant. Dissociation constant symbol is Ka. First, we before discuss this topic, uh, we discuss subtopic degree of dissociation. Degree of dissociation. This represent as alpha. Meaning of the degree of dissociation is how many mole convert or dissociate from 1 mole. This is the idea of degree of the dissociation. Think acetic acid. Example, acetic acid dissociate into acetate and H plus. We use 1 mole. Degree of dissociation alpha. What is the dissociate mole from 1 mole? Alpha. Form acetate alpha H plus alpha at equilibrium point 1 minus alpha, here alpha alpha. Think acetic acid, where we put 2 mole. How many mole dissociate? From 1 mole dissociate alpha. From 1 mole dissociate alpha. We have 2 mole. How many moles dissociate? 2 alpha. 1 mole alpha. We have 2 mole dissociate 2 alpha. Form acetate 1 to 1, 2 alpha H plus 2 alpha. At equilibrium point 2 minus 2 alpha, here 2 alpha 2 alpha. Now we can know idea of the degree of dissociation. Let's discuss dissociation constant Ka. Here we discuss Ka for monobasic acid. Ka for monobasic acid. Monobasic acid we represent as Ha, and aqueous medium. This acid dissociate partially, form H3O plus and A minus. We can write equilibrium constant Ka, not Ka, equilibrium constant K. K mean equilibrium constant. K is equal to H3O plus AQ 1, A minus AQ 1 over HAAQ 1 H2O liquid 1. Now we can simplify this H2O multiplied from K into H2O 1 equal H3O plus AQ 1 A minus AQ 1 over HA AQ. At when T constant, we know T constant, K is constant, we know water concentration is constant, therefore multiplication between two constant we can get one constant, this constant equal to Ka, therefore we can write Ka H3O plus AQ A minus AQ over HA AQ. This is the equation we use to calculate now we see HF aqueous medium, dissociate H3O plus AQ F minus AQ. What is the Ka for HF? HF Ka equal H3O plus AQ 1 F minus AQ 1 over HF AQ 1. Write this acid for Ka, acetic, HNO2 benzoic Ci C6H5COH. Right? For this monobasic weak acid for Ka, let's see Oswald law of dilution. Let's see Oswald law of Oswald law of dilution. Scientist Oswald proposed law for monobasic weak acid. This law proposed to monobasic weak acid. We get HA monobasic weak acid AQ dissociate into H3O plus AQ A minus AQ. We use starting concentration as C MOL Dn minus 3 at the starting point at medium, not H3O plus and A minus ions. For get equilibrium, this HA acid convert into H3O plus and N minus. We use degree of dissociation HA acid is alpha. Now we have C MOLDN minus 3 solution. It means in 1 cubic decimeter HA acid moles have C mole. We know in have 1 mole, if have 1 mole, dissociate alpha, in here have C mole, therefore dissociate C alpha. Concentration change C alpha from HA 1 to 1 ratio form H2O plus C alpha A minus C alpha. At equilibrium point, concentration of HA C minus C alpha H2O plus at starting 0 form C alpha, at equilibrium C alpha same to A minus C alpha. Now we can write Ka for this monobasic acid. We know Ka equal H2O plus 1 A minus 1 over HA 1. Now apply this symbol for this equation Ka H2O plus C alpha A minus C alpha HA C minus C alpha. Now we can simplify C alpha we can full C here in the bracket 1 minus alpha. Now we can cancel out C. Alpha degree of dissociation is very low value with compare 1. Normally weak acid degree of dissociation very low value, therefore when compare 1 this alpha is very low, therefore we can write 1 minus alpha similar to 1. Now we can modify this equation Ka equal C alpha into alpha over 1 minus alpha, we can write 1. Now we can write Ka equal C alpha square. Now this is the Oswald law for dilution. We can write alpha Ka over C square root. Degree of dissociation alpha equal Ka over C. This is the Oswald dilution law. Now if you want get the equation for pH weak acid, can use this alpha. We know H2O plus equal C alpha C. Now we can apply for alpha Ka over C. Now we can simplify this C can get enter to the square root. When enter to the square root, so it become C square Ka over C. Now can simplify this C Ka square Ka no H3 plus equal Ka C square. This can write Ka C 1 over 2. pH equal minus log H2O plus. Now we can put minus log for H2O plus Ka C 1 over 2. If you want, you can modify this one. This 1 over 2 can get here minus bar minus 1 over 2 log Ka into C. Now we can again modify this minus 1 over 2 common to Ka. Now we can write this one minus log Ka plus 1 over minus log 1 over 2 log C. Now minus log Ka plus into minus minus bar log C. This is do not memorize this equation. You want to memorize only pH equal minus log H2O plus. If you know this one, we can modify any equation from here. Now let's see how to compare acidic strength. How to compare acidic strength. Weak acid. When increasing Ka value, increase acidic strength. Example, for HF Ka 3.5 into 10 to the power minus 4 mol Dn minus 3. For acetic acid, Ka equal 1.8 10 to the power minus 5 mol Dn minus 3. Which one is the high acidic strength? Which one have high acidic strength? HF have high acidic strength than acidic. Why? Ka HF larger than Ka acidic. Now we see what is happening dilute what is happening when dilute weak acid. We know here have weak acid. when dilute. We know weak acid or strong acid when dilute, what happen? Increase the pH. Increase the pH. Think we have weak acid pH equal 3. When we dilute, when add water, pH increase up to 7. But we discussed previous video when dilute strong acid tenfold, pH increase 1 value. But when dilute weak acid tenfold, do not increase pH from 1 value. pH increase but not 1 value, it lower than pH increase lower than 1. It means think we have pH equal 3, dilute tenfold. Here pH between 3 and 4. Here pH larger than 3, smaller than, here pH larger than 3, smaller than 4. Why? When dilute the acid, pH should increase, but when dilute tenfold, do not increase the from 1 unit, it lower than the 1. Now let's see some question. pH weak acid. I will discuss 2 questions. Another question you should calculate the answers. First one, I discussed this one. The ionization constant of acidic is 2 into 10 to the power minus 5 mol Dn minus 3. At 25 Celsius, calculate degree of dissociation in 0.3 mol Dn minus 3 solution. Number 1, acetic acid. CH3COO minus AQ H3O plus. Starting concentrate acetic acid is 0.3. At the starting point, aqueous medium not acetate than H2O plus. See change. We use alpha for degree of dissociation. Here we have 0.3 mol Dn minus 3. concentration change 0.3 alpha, here 0.3 alpha, here 0.3 alpha. At equilibrium 0.3 minus 0.3 alpha, here 0.3 alpha, 0.3 alpha. We can write Ka for this equilibrium acetate 1 H2O plus 1 acetate 1. Now apply this value 0.3 alpha, 0.3 alpha, 0.3 minus 0.3 alpha. Now we can simplify 0.3 alpha into 0.3 alpha. We can pull 0.3, 1 minus alpha, cancel out 0.3. Now Ka 0.3 alpha square over 1. Now we know Ka, Ka 2 into 10 to the power minus 5, 0.3 alpha square. Now alpha square we can write 2 10 to the power minus 5 over 0.3. This can write alpha square 20 into 10 to the power minus 5 over 3. Now can simplify 6.6 10 to the power minus 5 square. Now we can write 66 into 10 to the power minus 6 alpha square. Now we can get alpha. We know 10 to the power minus 6 square equal 10 to the power minus 3. Now we can get 66 square, thus should get log for 66. 1 plus 66 0, 66 0, 8195, 8195. For get square, divide from 2, 0 9 0 9 7. Now get antilog for this number 9097 81 2, 81 2. Here have 0, therefore in decimal point in near to 8. Alpha equal 8.12 into 10 to the power minus 3. If you want to pH for this question, pH equal minus log H2O plus. We know minus log H2O plus C alpha. C equals 0.3 into 8.12 10 to the power minus 3 minus log 6 3 24 decimal point 123 here. Now minus 4 minus 3 bar 3 plus 0 24 3 24 3 3856 3856 minus into minus plus 3 3856. Now we can simplify 10 minus 6 4 9 minus 5 4 9 minus 8 1 9 minus 3 6 2 minus 0 2. This is the pH. Now I think you can understand this theory part. Therefore, calculate this question. Second question is the ionization constant of HNO2 is 4.5 10 to the power minus 4 mol Dn minus 3. Calculate the degree of dissociation in 0.2 mol Dn minus 3. Third question, the pH of 0.2 mol Dn minus 3 monobasic acid is 5. Calculate the concentration of species H plus, A minus and HA at equilibrium. Also determine value of Ka. Number 4, the pH of 0.2, here have 0.2 mol Dn minus 3 HF acid is 2.1. Calculate the concentration of species H plus, F minus, HF at equilibrium. Also determine value of Ka. Number 5, prove that for monobasic weak acid for POH equal pKw minus pKa plus log HA over F minus. A minus, here HA over A minus. This is this question done. Send answers to me. Next video we will discuss answers for this question and basic weak acid dissociation constant.